Okay, so when you think of a really destructive storm, what's the first thing that pops into your head? Probably a big, swirling funnel cloud, right? A classic tornado. But what if I told you there's another threat out there, one that's way more common and sometimes just as deadly, and you can't even see it? We're going to dive into this invisible killer.
I want you to picture this. It's August 2nd, 1985. We're at the Dallas/Fort Worth International Airport. Delta Flight 191, this huge Lockheed L-1011 with 163 people on board, is making its final approach. But the weather is turning nasty. Things are about to get very, very real.
So in the cockpit, what should have been a totally routine landing suddenly becomes a fight for their lives. First, bam, a massive headwind slams into the plane. Airspeed shoots up, the pilots are trying to compensate, but just seconds later they get hit by this violent downdraft. I mean, it's a column of air literally punching the jet down toward the ground. And if that wasn't bad enough, it's immediately followed by a tailwind, which just kills their lift. The pilots fought it, they really did, but it was just too much, too fast. The plane went down just short of the runway.
Now, the thing that brought down Flight 191, it wasn't a tornado. Nope, it was something much more common. But in that critical moment, during landing, it was absolutely lethal. So what was this invisible killer?
The culprit? It was a microburst. It's a very specific, really intense type of downburst. And you know, the tragedy of Flight 191 was a huge wake-up call. It basically forced everyone to realize there was this major gap in our weather knowledge, and we had to figure out the difference between a tornado and this, well, this less famous but just as ferocious cousin. All right, so what really separates a tornado from a downburst? It honestly all boils down to one super simple, fundamental difference. It's all about which way the air is moving.
This is it right here. This is the core concept. For a tornado, just think in. All the wind is flowing inward, converging, and then rotating violently up. For a downburst, think out. You've got a column of air that sinks, smacks the ground, and then blasts outward in all directions. It's really that simple. One sucks in, the other pushes out.
So downburst is kind of the main category for this kind of thing. Meteorologists basically break them down by size. You've got the microburst, that's what hit Flight 191. It's small but super intense, usually covering less than 2.5 miles. Then you have the macroburst, which is just a bigger version, but they both work on the exact same destructive principle.
Here's the best way to picture what's happening. Seriously, go try this later. Turn on your kitchen tap, full blast. You see how that stream of water hits the sink and just explodes outward in every direction? That is exactly what a downburst does. Just swap out the water for a massive column of cold, heavy air.
And this powerful outward blast, that's what creates what experts call straight-line winds. And this is a huge, huge clue. See, a tornado leaves this twisted, chaotic mess. But a downburst? The damage looks like everything just got pushed over in one direction, fanning out from where it hit the ground. Okay, so we get it. Their wind patterns are total opposites. But why? Well, it's because they're basically born from two completely different engines inside a thunderstorm. Let's break down how each of these things actually gets started.
A downburst is pretty much a story of collapse from the top down. It all starts when rain or hail falls out of a thunderstorm, but it falls through a patch of really dry air. This makes the rain evaporate super fast, and evaporation cools the air around it. All of a sudden, you have this pocket of cold air that's way denser and heavier than all the warmer air around it. And what does heavy stuff do? It falls. It plummets, picking up speed, until it slams into the ground and explodes outward. It's a total top-down event.
A tornado, on the other hand, is completely different. It's a story of rotation that gets built from the bottom up. It starts with a thing called wind shear. That's just a fancy way of saying winds at different heights are blowing at different speeds or directions. This creates this invisible horizontal tube of spinning air just rolling along. Then, a powerful updraft in the storm can actually grab that spinning tube and yank it upright, vertically. If that rotation gets tighter and stronger, a funnel cloud can stretch down to the ground, and boom, you've got a tornado. So, because they form in such different ways, they leave behind completely different fingerprints of destruction. I mean, after a storm, investigators can literally read the wreckage on the ground and tell you exactly what happened. And here's how they figure it out. A tornado, with all its rotating winds, leaves a total mess. Debris is just thrown everywhere at all kinds of crazy angles. But a downburst, with its straight-line winds, it's much more orderly. It looks like everything got knocked down in neat parallel lines, kind of like dominoes, all pointing away from a single spot. That is the key piece of evidence they're looking for. And please, don't make the mistake of thinking downbursts are the weaker cousin here. Not at all. A powerful microburst can crank out winds up to 168 miles per hour. To put that in perspective for you, that is way stronger than an EF1 tornado. These things can cause absolutely massive damage.
What's really cool is that these differences aren't just something you see in the wreckage afterwards. They actually create unique signatures on weather radar, so meteorologists can spot them forming in real time.
Okay, so on a radar screen, a storm that's making a tornado often has this classic hook echo. That little hook shape is a dead giveaway that there's rotation happening inside the storm. A downburst, though, that often creates a bow echo. It looks like a line of storms is bulging outwards, like an archer's bow being pulled back. That bulge is being caused by powerful straight-line winds pushing from behind. These are the kinds of signatures meteorologists are trained to hunt for.
And what about for us down on the ground? Well, there are visual clues you can look for too. If you ever see virga, that's when rain is falling but it evaporates before it even hits the ground, leaving these kind of wispy trails. That can be a big red flag for a dry microburst. Another one? A sudden ring of dust getting kicked up on a day that seems pretty calm. That's a huge sign of a downburst hitting the ground. And of course, the obvious one, if you see a funnel cloud, that's the unmistakable sign of a potential tornado.
So there you have it. Two very different threats that can come from the exact same sky. And look, understanding the difference isn't just for weather nerds. It's actually critical for staying safe, whether you're in a plane or just at home.
And get this, here's a stat that might actually blow your mind. For every 1 report of tornado damage in the US, there are about 10 reports of damage from downbursts. Yeah, they are so much more common, which is exactly why we need to understand what they are.
And that brings us right back to where we started, with Flight 191. What happened to them perfectly illustrates the deadly trap a microburst sets for an airplane. You have that insane rapid-fire sequence, headwind, downdraft, tailwind. It all happens in just a few seconds, usually when a plane is low to the ground taking off or landing. It leaves pilots with practically zero time or room to recover. It's this unique, devastating threat it's different from what a tornado presents.
So now you know. You know the difference between the rotating fury of a tornado and that crushing blast of a downburst. You know the signs to look for, you know the science behind it, but here's the real question, right? The next time a severe thunderstorm warning pops up for your area, a storm that could cook up either one of these things, do you have a plan? Because look, knowing the difference is great, it's the first step, but being prepared, that's what's actually going to keep you safe.